Hi, welcome back to another episode of Algebra and Words, the video series on YouTube. We're going to continue our discussion of two systems of linear equations, and specifically focusing on the substitution method. If you like to follow along in written form of the substitution method, you can follow along with that on page 61 in my book Algebra and Words, which you can find on Amazon. The link for that is below in the description box. So let's get started. And before we do the math, I want to just give an overview of the steps involved in this method. Okay, so here's what we're going to do. Now, first of all, it's important to analyze the given problems. Ultimately, when you're solving a system of two linear equations, you can ultimately use any method that you like. Either the graph and check method, which most people usually don't like, unless you have to do it, the substitution method, which we're going to do here, or the addition-elimination method. Whenever you have the choice, there's sort of certain looks to the problem that will indicate what the best or most efficient method is to use. Now, specifically, notice how, let's look at the coefficients of the variables. Notice how this has a coefficient of 1, and this has a coefficient of 1. Well, when one or more of the variables have a coefficient of 1, to me, that's a good indicator to use the substitution method. And why do I say that? Because it's kind of less work to do, and sort of one step of the problem is already done for you. Because the next step is going to involve rearranging one of the equations to solve for one of the variables. Once you solve for one of the variables and get everything else on the other side of the equation, take what that variable equals, substitute it in for that variable into the other equation, and then simplify down, because then you'll be working with one variable only. You can solve for that variable's value, and then take what that is, substitute it into one of the original equations to solve for the other value, and then you'll have both. Okay, so without further ado, let's get started. Now, since this has a coefficient of 1 and the y has a coefficient of 1, does it matter which we solve for? No, just randomly make a choice. I'm going to choose x. So I'm going to rewrite this. And we're going to solve for x, so we're going to move everything else to the other side, meaning I'm going to subtract y from both sides. That's going to leave x equals negative 10 minus y. And now, I'm just going to rewrite this again, like this. Because I want you to see that we're going to take what x equals from the top equation and substitute it in for x in the bottom equation. So let's do that. 4 times the quantity negative 10 minus y. Don't forget to write everything else. Minus 7y equals 15. And now, distribute the 4 through the parentheses. We're going to get negative 40 minus 4y minus 7y equals 15. And now let's combine like terms on the left. So we're going to have negative 40 and combine these terms to get negative 11y equals 15. And now let's isolate the term of the variable, and let's add 40 to both sides to move that over to the right side. And I'm just going to move this up here. We're now going to have negative 11y equals 55. Divide both sides by coefficient negative 11, and we get y equals negative 5. So what I like to do for problems like this is put a set of parentheses, and whichever variable you solve for first, because remember the solution is a point, put that value into the point. So I'm going to put negative 5 into the point. Now that we found negative 5 for y, we're going to take the negative 5 and substitute it back into one of the original equations. It doesn't matter which. Try to choose the easier one if you think you can identify it. And to me, that would be the top one. So we're going to substitute, we're going to write x plus negative 5 for y equals negative 10. And x minus 5 equals negative 10. Add 5 to both sides. And we get x equals negative 5. Let's put the negative 5 into the point. And our final answer is negative 5 by using the substitution method. Okay? If you're asked what type of system this is, we would say it's a consistent system of independent equations, and there's one solution, which we just found. So that was the demonstration for the substitution method. I'm going to pause this video and do one more. Okay, so I have the next problem up on the board. And again, we have two equations. Okay, we are going to do the substitution, but suppose we didn't know that yet and we had the choice. Let's just analyze the equations and see if it's a good fit for substitution method. Well, first, right off the bat, we see x alone, right? We see x with a coefficient of 1, and to me, that's a good indicator to use the substitution method. The next thing that you would do is to solve for x, but if you notice, the form that the equation is given is already solved for x. So really, one step is already done for you. The next thing for you to do now is to take what x equals and substitute it into this x in the other equation. So let's do that. 2, and then parentheses, 3y minus 4 plus 5y, rewriting this and this, equals 3. And now let's distribute this through and continue to simplify. 2 times 3y is 6y. 2 times negative 4 is negative 8. And we have plus 5y brought down equals 3 brought down. And now on the left, let's combine like terms. We have 6y and 5y, which combines to 11y, minus 8 from here equals 3. And now let's move the 8 to the other side by adding 8 to both sides. So we get 11y is equal to 11. Divide both sides by coefficient 11. And we get y equals 1. Let's put that into the point. And that tells us that next we have to solve for x. We're going to do that by taking y equals 1, 1 in for y, and substitute it into either of the original equations. I'm just going to randomly choose the top equation. So we're going to write x equals 3, and in for y goes 1 minus 4, and let's just simplify. 3 times 1 is 3, minus 4 is going to give us x equals negative 1. Put the negative 1 into the point, and our final answer is negative 1, 1. And that's the answer to the problem. Okay, if you were to be asked what type of system this is, it's a consistent system of independent equations, and it has one solution, which we just found. So anyway, that's substitution method. I hope you found it helpful. If you did, please give a thumbs up. Please share with your friends. Please leave feedback in the comments section. And please subscribe to the channel so you can be alerted when new videos come out. Also, be sure to check out more videos of related content on Facebook and Instagram. And I'll see you next time.